Today we're going to start finding the area of trapezoids. To do so, first I need to know which sides are my bases. So the bases are always the sides that are parallel to each other. So in this case, that's the top and the bottom. It is possible for your bases to be on the left and right if I took this trapezoid and turned it on its side. For this trapezoid, I have one base that has a length of 1 unit, and then I have a base that has a length of 5 units. The height of a trapezoid is the perpendicular distance, or that right-angled distance, between the two bases. So if I start at one base and I count straight line to the other, I have 1, 2, 3 units between them. So one of the ways that I can find the area of this trapezoid is by cutting it into shapes that I already know. If I cut this trapezoid into a rectangle and 2 triangles, it makes it a little bit easier for me to find its area. This rectangle now has side lengths of 1 and 3, which means that my area of that rectangle is 3 square units. This triangle has a base of 2 units and a height of 3 units. Remember that a triangle has the area of half of the rectangle that it's inside of, and so if my rectangle was 2 by 3, that would be 6. Half of that is also 3 square units. This triangle, in this case, is exactly the same as the triangle on either side. I have a base of 2 and a height of 3. We already said that gives us an area of 3 square units, so it still gives us an area of 3 square units. Together, I have 3, 6, 9 square units inside of my trapezoid. Another way to think about this is similar to the way that we did with parallelograms. If I were to cut along this dotted line to cut off that triangle, and I flipped it over and added it onto this side, I could turn this trapezoid into a rectangle. And now, instead of having a base of 1 and a base of 5, I would have a rectangle that had a base of 3 on both sides. So it's a little bit different than when we did the parallelogram because we're actually changing the side of the base. The 2 units that we cut off the bottom are being added to the top instead of being added to the bottom on the other side, the way that we did with the parallelogram. And so the formula to help me find the area of my trapezoid is by averaging the lengths of the 2 bases. So adding them together and dividing them by 2. Because that's the same thing as if I cut these 2 pieces off and add them on this side so that the 2 bases become the same length to become that rectangle. So then I would have 3 on this side, and I would have 3 on this side. And then my height would stay the same. This trapezoid looks a little bit different, but it follows the same principle. Now I have 1 base of 3 units and 1 base of 5 units. Again, I could go ahead and cut off this triangle, flip it over and put it on this side, and then I would have this base would be 4, and this base would be left by 4, because I cut 1 from the bottom and add it to the top. So I'm finding what's the number that's halfway in between these 2 numbers so that those 2 lengths can be the same to make it into a rectangle. So once I do that, I could say that I have 4 by 3 in my rectangle, which gives me an area of 12 square units. The other way I can do it is just like we did before, cutting it into these 3 shapes and finding them separately, then adding them together. So here this center rectangle happens to be 3 by 3, so that gives me an area of 9 square units. And then the 2 triangles on the side, again, are identical. They each have a base of 1 and a height of 3. So 1 times 3 is 3, divided by 2 gives me 1.5 on this side and 1.5 on that side. 1.5 plus 1.5 is 3, plus 9 gives me 12 square units, just like when I turned it into a rectangle. This trapezoid looks a little bit different. We call this trapezoid a right trapezoid because it has a right angle built in where one of the sides meets the bases. So keep in mind that because these two bases are parallel, if you've got a right angle on one side, you also have a right angle on the other side. And this side can then be used as my height. So here, I only have one triangle to cut off. The rule still works that I can average together my two bases so that they become the same length. And it's a little bit trickier to see, but here's how it works. In this box, I have this little tiny triangle, but I'm missing this larger piece. The opposite is true of this box in this corner. I'm missing this little tiny triangle, but I have this larger piece. This is actually a trapezoid. If I take this trapezoid and I flip it up here, it completes this box, and now this box is empty. I can do the same thing here, where I can take this little tiny triangle and I can fill it in where this triangle is missing over here. Now, these two boxes are full, these two boxes already were, and these two boxes are empty, leaving me with 6 units on the top and 6 units on the bottom, because remember, now it's going to end here. And then I still have a height of 4, and I can do 6 times 4, which is 24 square units. The other option that always exists is finding the area of the two separate pieces. So here I have a rectangle that's 5 units by 4 units, which gives me an area of 20 square units. And here I have a triangle of 4 units for the height and 2 units for the base. If I didn't have this on a grid, I could see that because this side's 5 and this side's 7, that I must have 2 extra units, because 7 minus 5 is 2, to make up that triangle. So the area of this triangle is 4 square units. 20 plus 4 gives me 24 square units, which is the same that I had when I turned it into a rectangle that was 6 by 4. This trapezoid looks a little bit different than the ones we were looking at earlier. It's closer to a parallelogram, but it's still not quite there. My bases are different lengths, which means that my two other sides are not parallel to each other. So again, I can do the same that I was doing before. I can average the lengths of these two sides. That would give me a side length of 6.5. And then I can work with my 6.5 and my height of 4 in order to find the area of that rectangle. Or I can take my shape and cut it into a rectangle and 2 triangles. Now my rectangle has a width of 1, 2, 3, 4, 5, because remember we cut 1 off here and 2 off here in order to make this work. So I end up with 5 and a height of 1, 2, 3, 4. So that means that this area inside here is going to be 20 square units. The triangle on the side has a base of 1 and a height of 4, which gives it 2 square units. In this case, my triangles are not identical, so I have to make sure that I find the area of each one. This one has a base of 2 units and a height still of 4 units, same as all my other shapes. So in this case, my area is 4 square units. If I add these pieces all together, I get 20 plus 4 plus 2 is 26 square units. Check and see if the math works. If you did 6.5 times 4, would you still get 26 square units? Now we're looking at a trapezoid that's not on a grid. So it makes it a little bit trickier, but it doesn't have to be. I can use my same rules about averaging my side lengths together, and I could take this triangle and flip it over and stick it on this side and make myself a rectangle. It won't always be an isosceles trapezoid, which is what this is, where the two triangles on the side are the same as each other. However, those rules still work. So if I were to break this into triangles and rectangles, it doesn't matter how I choose to split up my sides as long as all of the pieces get included. So I could say that this 7 centimeters is centered on this 11 centimeters. And to get from 7 to 11, I need 4 extra centimeters. So I could say that there's 2 centimeters on the side and 2 centimeters on the side. If it's not centered, and I say there's 1 centimeter on this side and 3 centimeters on this side, if I add all my pieces together, it will give me the same answer. So as long as this is being split up in such a way that it does equal 11, it doesn't matter how I choose to separate them. So it's okay to take a guess if you're not sure. Again, always will work is if you average together these 2 side lengths and turn it into a rectangle. See if you can go ahead and find the area of this trapezoid. Draw it in your notebook. Use any method to help you find it, and then go ahead and check your answer with me.